Hello, my name is Adam Maskal. I'm from Solmax Geosynthetics, located in Central California, and today I will be presenting a case study that we had the pleasure of looking at recently. It's the Putah South Canal in California, just northeast of the San Francisco Bay Area, and it has been in service for 25 years, and we recently had a chance to take a look at it and see how it was doing. Today I'll be giving you a little bit of background about water in California and why we rely so heavily on canals and why there are so many canals. A bit of background about the Solano Irrigation District just for context, the Putah South Canal itself, some construction details, and the condition that it's in after visiting it 25 years after it was placed into service. And then also a few lessons learned that I think will be useful for folks looking to line canals moving forward. First, I'll talk a little bit about the history of water in California, the climate and water demand. Gives a little bit of context for the canal system that we use. And here's a nice map that shows the prime farmland in California. The green areas and red areas are both prime farmland. The red areas are near urban areas that also compete for the limited amount of water that's available. Also important to note, the Los Angeles area with about 19 million people has nearly a 2 meter per year demand for water. And that big farm area in the central part of the state is the San Joaquin Valley. It's also referred to as the food basket of the world. It has up to a meter of irrigation demand per year, but that area is about 1/4% of the U.S. landmass and provides nearly 13% of all agricultural products in the U.S. Here is a map that shows the really diverse precipitation in California. Quite extreme conditions from one end of the state to the next, starting with the Mojave Desert down near Arizona and southern part of Nevada. That area gets less than 5 inches of rainfall per year, or less than 13 centimeters of rainfall per year. The Los Angeles Basin, again, needs up to 2 meters of water per year worth of rainfall if it were to fall in that area. They only get somewhere between a quarter and a third of that amount. And the San Joaquin Valley, they can have up to a meter. They get somewhere between 12 and 40% of the water that's needed. And in stark contrast, the far northern part of the state and the Sierra Nevada mountains that run along the east side of the San Joaquin Valley, they get quite a bit of precipitation, up to 300 centimeters per year in the far northeast corner of the state, and a little less than that, but still quite a surplus of water throughout the rest of that area. Putting together the rainfall and the water demand throughout the state, California has a relatively interesting water balance. The far north end of the state, there is, again, upwards of 3 meters of rainfall per year in some areas. And in the San Joaquin Valley, there's about 1/2 meter per year of water deficit. And in the Los Angeles Basin, there is about a meter almost a meter per year of water after water imports from other parts of the state and from other states. For context, you can see the major canal systems on the map on the left. That's just the major canal systems used to get water from one end of the state to the other. And from Red Bluff to San Diego is about 700 miles or 1,100 kilometers. So you can see there are hundreds and hundreds of miles of canals in just this system. The Solano Project is not part of that major system. It's more of a local system. It is on the Putah Creek. Here's a little bit more detailed view. Putah Creek has Monticello Dam, which forms Lake Berryessa, There's the Putah Diversion Dam that diverts water into the Putah South Canal. That canal is about 40 miles or 65 kilometers long, serves a few areas around cities, making agricultural water for those fertile farm grounds that surround those cities that are in the area there. And Putah Creek runs over from Lake Berryessa, which is about halfway over the coastal mountain range, and the creek runs down into the Sacramento Basin. Here's the canal design. It is about 8 feet width on the bottom, or 2.5 meters. And if you'll note, there are expansion joints. I'll go to the next slide that has a little bit more magnified view. Again, 8 feet or 2.5 meters wide on the floor. Side slopes sloping up from there, an additional about 3.5 or 4 meters on each side. And again, expansion joints in the plan view. And here's a cross-section view. Again, shows the widths. The side slope at about 1.5 horizontal to 1 vertical. And the cross-section of the liner itself is a 2-inch thick or 5 centimeter fiber reinforced shotcrete layer on top of an 80 mil or 2 millimeter blown film textured high-density polyethylene geomembrane. And that is placed over the top of reinforced concrete that's there for structural purposes. And here is a detail that shows the expansion joint, which is critical to the design of using the thin shotcrete layer on top of the geomembrane. In this case, it's about 1 centimeter wide or 1/2 inch wide, radius corners, and nearly 1 inch in depth, or about 2 centimeters in depth. And you can see the detail on the blown film textured geomembrane with a very rough, irregular shape on the surface that helps the shotcrete cling to it. And here's a photo from 1993 when a section of the liner was being installed. You can see the structural concrete, there are expansion joints in it also, just like any structural concrete slab would have. The textured 80 mil geomembrane being placed, and the shotcrete was then applied over the top of that. And here's what it looks like today. The expansion joint on the left, that's a shallower example of the expansion joint. It looked like there was a little bit of concrete, but you can see it still contained the cracks quite well, and there are some significant cracks in the expansion joint between the panels. The cracks were contained to the expansion joints, and you can see in the photo on the right that the panels are largely intact. There are some weeds growing up out of the expansion joints there on the far bank, and lots of dry grass, which is why that area has been hit by pretty significant fires. Here's another photo showing another view of the same canal in a different section. And again, you can see a few weeds growing out, but the canal liner itself is in remarkable shape. So what can we say about the Putah South Canal after over 25 years in service? Some lessons learned. First off, we know that the HDPE geomembrane that's really widely available and kind of standard for environmental projects, that encased in concrete has proven to be a very cost-effective and lasting canal lining system. The 2-inch thick or 5 centimeter thick fiber reinforced shotcrete armoring layer was applied directly to it. The blown film texture was enough to allow the shotcrete to cling to the geomembrane and adhere to it, so that would stay on the slope for floating, finishing, and scoring of the expansion joints while that was wet. The expansion joints themselves were 1.5 to 1 inch deep, or 1 centimeter by 2 or 2.5 centimeters deep. They were wet formed expansion joints formed in when the shotcrete was still wet. Those are at about 3 meter increments or spacing across the whole width of the canal, And they did a great job of containing the cracks in the shotcrete so that the panels remain intact and adhered to the geomembrane. There was virtually no dislodgement of the shotcrete layer observed, and the canal is in very serviceable condition without any significant damage after 27 years in service now.